Hi everyone. So I'm Mike Simonson on Twitter. I'm a web developer. I am one of the maintainers of Doctrine, for those who know the tool. I'm also the organizer of Brussels PHP, if there are people from Brussels that are interested. Or if there are people that know any company that is willing to host us, I'd be very happy to talk with you after the talk. And I also worked at Cube Solution. Whenever I'm not behind my computer, you can probably find me hiking somewhere outdoor. Now that part is done, what do you mean white screen? No, it's apparently... Wait. Sorry. Nope. I can... No, it's apparently the best I can do. So I suppose everyone here is a PHP developer, but who here is used to doing TDD at work? Okay, quite a few people. Who is doing TDD like for more than 5 years? I mean, that is quite experienced. Okay, I hope I'm still gonna give you a few tricks, but this talk is basically everything that I've learned along the way going to conferences and meeting people from very different backgrounds. For instance, maybe some of you know Drawer Helper. I'm probably butchering his name, but it's a C# developer that gives a very similar talk in C#, but most of what he learned me is applicable in any language. And if you want to learn stuff about unit testing, he has definitely very interesting stuff to say. Who here works agile at work? Also, pretty much everyone. Who here works, I mean, their boss says that they work agile, but in fact they just do waterfall? Okay, so as I said, that talk is going to be mostly about my experience, but I think it's a lot of you will, based on your answer, a lot of you can relate to that experience. My first experience with unit testing was at school, where basically we were more teach how to delete the tests that just failed because we changed some piece of code, and just do something else, like test another part of the code than anything else. In a way, I could see that it might be useful, but it was very frustrating. After school, I went to a British company for my internship, and there they really practiced TDD the right way, I would say, or at least the first useful way that I had seen. It was a very interesting experience for me, because that was the first time that I could see someone developing new code using TDD in a way that wasn't cumbersome and wasn't just making me waste tons of time not knowing where I was going to go. Then I went to my first paid job. It was a very big company with lots of developers, and apparently no one was interested into building code that actually worked. So I was mostly trying to do tests myself, but I was the only one to run them. I was also the only one to write them, and the only one to fix them, because I was the only one to notice when they break. That was also very frustrating, but yeah, life goes on, and I changed job to go in a much smaller company where I was heavily encouraged going to conference like FOSDEM, and that's basically at those conferences that I learned most of what I know now. I'm mostly going to speak here about unit testing, but that's just one part of all the tests that you can do on your application. But before to speak about the different kind of tests to see where the unit test stands, there is also the pretty obvious question, like, when should we test? It's always a cost-benefit question. At some point, like, the product has to ship, and you have to get paid. So you have to know when to test and when not to test. Most of the time, I'd say that it's rather a question like, is that project going to live on after I've finished working on it? Like, am I going to give that project to this project responsibility to someone else? Is someone going to have to maintain it? If the answer is yes, then it's probably a bit, I mean, it would be nicer for him to test it. It's gonna simplify the job of the person that comes after you a lot. Especially because we live in an industry where we are asked to build prototype, and all those prototypes end up in production. So if you want to know when to test, basically ask yourself the question if you want your project to succeed or not. The unit test in the whole test scene is basically the one that is at the bottom. It's the test that is the closest to the logic of the code, the one that is the fastest to run because it has the least dependency. If your unit test has a lot of dependency, it's not a unit test anymore. It's basically a functional test or an integration test. And the fact that it's fast to run because it has no dependency make it cheap to run and make it interesting in the sense that if you run those tests a lot, then they are going to be useful. The only good reason to write a test is for the test to fail. If the test never fails, the test is just useless. It's just wasting time and space. I suppose everyone has seen a unit test. Here the example is in Java, but it's pretty much the same in any language. You just have a method in some random class that is marked one way or another, either way with an annotation or whatever else exists in your language that is similar to annotation and does the same job to mark that method is a test. What that gives you is effectively the fact that you can have a piece of code that can detect that automatically, and you don't need to program that part of the work. It's just going to pick up whichever test you have anywhere in your code and run them automatically. It's a contract between you and your unit testing framework. The first issue that I had when I was in that big company trying to implement and run the test myself was that I didn't really knew a lot of tools that could help me, and now it's really easy to use any one of them. I mean, they're all over the place. Any unit testing framework has its own test runner. You also have a build server that you can install to run your test on a separate machine. And you can even implement in really simple fashion a script that picks up every time you change your code and run the test. That way you don't even need to, either way, go out of your IDE. If you use one and run the test, it's just going to happen automatically. You can have on one screen your tests that are constantly running and work on the other without any issue. The build server is also important because, as opposed to what I was doing, it gives a way to show the test result to the other person in the team. I was the only one to run them, so I was the only one to notice when they failed. It's like, if someone cannot see the result of the test in the team, obviously it's not, that person is going to forget to run them at some point and then forget to use them completely. So installing a build server, if you're more than one person in the team, feels like a necessity to me. It became really easy now. There are templates for PHP projects in Jenkins. I suppose everyone knows Jenkins. It's really easy to set up now. You should definitely do it. There are also IDE runner for whichever IDE that you use. There is probably a test runner that's already integrated in it and can provide additional functionality, like just run the tests that cover that piece of code. Yeah. Now, writing those tests. You can basically be in two different situations. You're either way writing tests for a brand new project, or you're writing tests for existing code that you have to maintain. Let's face it, there is way more projects to maintain than new project to do, even though there is a lot of new project to do, but like, I suppose every one of you has had to maintain a project at some point. And it's the bulk of the work. If you have new code, it's obviously going to be easier to start doing TDD on that code. And in that case, I would encourage you to take a look at BDD tools, behavior-driven development tools. They are basically a little bit the same kind of tool that we have for unit testing for the code. They have the same behavior, but for the person that actually asks you the feature of that code. So by writing scenario in a behavior-driven development, it's going to guide you on what unit test you should write so that you can write the code that fulfills those unit tests and fulfill those scenarios. I'm not going to talk about those tools. There is a lot of documentation available pretty much everywhere. If you're looking for one in PHP, there is Behat, for instance, but there are other. It's just the most well-known. Sadly, if you're not in that case, most probably your code will have dependencies. Like often when you look at blog posts that describe how to do TDD, they use a calculator example. It's really nice because it's really concise, but none of the code that I wrote is actually so dependency-less than a calculator. And as I said previously, if you have dependencies and you use them in your unit tests, it's going to make the test slow. It's also going to be really hard to set up across the machine of all, reliably set up across the machine of everyone that's on the team, especially if you have people that are on Windows, others that are on Mac and Linux. And it's also going to be a pain to set up on the CI server if you have one. Some of those dependencies are a little bit more subtle than others. Often people don't realize that the time is a really annoying dependency. And I remember that when I was in London, one of the tests that I fixed was a test that failed 6 months on the year. And it was basically just an issue in a date calculation that wasn't taking into account the the daylight saving time. It's really hard to figure out that it's the issue if you don't see the time as a dependency of your code and try to extract that dependency in a very explicit way. One of the ways that I've seen people deal with those dependencies is creating what's called fake object. It's really simple to do. Here you have an example with the migration class of doctrine migration. It has a bunch of methods, and if you need to create a fake object for that, you just extend migration and override all the function, all the public function of that object without putting anything in the body of the function, and you have just an object that is really similar but doesn't do anything. It's really easy to do that, like if you start testing, but it's going to be a pain really, really fast, because every time you will change something in the object that you extend, you're gonna have to change it also in the fake object. That's a lot of code that you have to maintain yourself. Every code that you write yourself, you have to maintain yourself. And that's it. Now, there is also, who heard already about mocking frameworks? Okay, most of you, so I can probably go a little bit faster there. But it's basically a piece of code that will do that work for you automatically. So every time that you change something in your object, it can regenerate that fake object automatically. It can also provide a lot of additional functionality on top of that. For instance, you can verify that certain methods of your object have been called or have not been called, which is much harder to do if you implement the fake object yourself. Here you have an example of one of the mocking library that exists in PHP. It's called Mockery. There is also a lot of other. There is Prophecy, and even PHP Unit has its own mocking library. But Mockery has very interesting feature. Like, for instance, one of the things that's annoying when you have a lot of stuff to mock in your code is that sometimes you have to create a lot of mock objects that return each other until you have actually mocked the dependency that you wanted to mock. And you can do that at once with Mockery, which is nice. Although it might mean in the first place that your code has a problem of structure if you have so much to mock. But if it's just code that you have to maintain, it's a really quick fix before you can refactor that piece of code. Any question yet? Nope. Okay. Now, I don't know if anyone heard about auto-mocking container. No? Okay, I'm going to learn you something. Sadly, that's not something that exists in PHP yet. At least I couldn't find any implementation. But it's that idea that in most framework now, they have a dependency injection container that you configure so that it can create the object that you need in your application. And they reuse that container to automatically generate mocks. So because that dependency injection container already knows how to build the actual object, it can really easily create that object, only passing it mocks. So you have actually the real object, it's just cannot do anything on its own. Now the time dependency. The solution to fix the time dependency is basically to pass the time every time you need to use it. If you have datetime now anywhere, or datetime without any parameter anywhere in your code, it's going to make that piece of code really hard to test. And you should probably pass that information at creation time. So it looks like that piece of example is okay. Sorry, this is actually showing how you can do that, pass the time without having to change too much. If you do it at first, you can implement an interface, a clock interface that just returns the current time, and then you can implement two classes, a system clock that just do that, return daytime now, and a mock clock that is going to return the time that you decide in your test. Okay, I'm sorry for the order of the slide here, but yeah, the first one was showing the problem. But here, by passing the clock and asking the clock the current time, we have actually fixed our dependency issue to the time. If we have any test that needs it, we can just replace the system clock by the mock one and pass it the time that we want to use in our test. It's mostly useful if you are making calculation, but it doesn't take a lot of time to implement, so I would recommend to take a look at that solution. Now, it's all good, but we also have a big problem in the documentation of this, of the unit testing framework in general, because they never really explain you how you should structure your test or how you should write them, because you have that freedom in that method of your unit test where you can do anything you want. Yeah, it's maybe a little bit hurtful in that sense. And often the information that you can find, at least in my opinion, make you end up with tests that are really hard to maintain. Maybe we can come back to the definition of a unit test. It's an automated piece of code. That's a really important one because at the company where my girlfriend worked, they had unit testing that they told her while they hired her. It was just some person with an Excel sheet file that was just running the test by clicking on the button in the interface. That's not a unit test. It's a unit of work of the system. That one is really hard to define. I've not seen anyone yet that could give me a proper definition of that. The only thing that I can tell you is that, to me, a unit test, it's a test that tests the smallest possible blocks of code, and you can check that if you use code coverage. Often you will see people that use code coverage as a sort of a vanity thing on their README on GitHub. Yeah, I have 100% code coverage, but that doesn't give you any indication on the quality of those tests. If they are easy to understand, like, what they're actually testing, and if it's going to be possible to modify them or not. That test should check one and only one assumption about the code. That one is a really important one. As a doctrine maintainer, I sometimes read pull requests where we have tests that are like 200 lines of code, and you will see someone that do something, then assert something, then do something else, then assert something else, and it's actually impossible to understand what he's trying to test or what he's trying to do in that test. Test one thing, put what you're testing in the name of the method, and the person that comes after you is going to bluff you. It doesn't actually still give you a lot of information of the structure of the test. Yeah. As I said, one of the important stuff to test the quality of a test is to make it fail first. If the test didn't fail, you can never be sure that it actually tested what you expected it to test. That's something that happened to me countless times, writing tests, thinking that they work and never see them failing because they were actually not testing what I thought at all. As I told you, the code coverage, which is the really way better used trying to determine what you are testing than trying to give you a good feeling by showing a high percentage. The best way you can use the code coverage is trying to cover only one test. You run one test and you see how much code it's covering. If it's covering hundreds of lines, it's not a unit test anymore. It's probably going to be slow, and it's going to be much harder to understand what it's trying to test. Okay, what is that example? I'm sorry. Yeah, that's the test that is trying to test. No. That's another problem of the code coverage. Often, you can end up with 100% code coverage, and you think you're safe. Except that in that case, you can write 3 tests that will give you 100% code coverage, but they're not giving you, they're not testing all the possible scenario that code can be in. Because actually, maybe it's better asked, like, how many tests do you think you have to write to cover all the scenario of that example? So, who says 3? Who says 4? 5? 6? 27. How do you reach that number? 3 power 3. I think it's 3 factorial, but I'm not sure. I would say it's 3 factorial 3 to be sure that you pass in all the if, and then 1 more because you could pass in none of them. But anyway, it's that piece of code could give you the impression that your code is tested, and it can still end up in a situation that you did not expect. How can you detect that? It's really hard to know if your test is good, and the only tool that can help you do that is mutation testing. Any one of you heard about mutation testing? Okay, quite a few people. For those who don't know, again, it's the idea to try to use the code coverage in a slightly different way. We have a PHP tool to do that. It's called Humbug. It's actually going to run your test using code coverage, so it can map each test with a piece of code that it's covering. And based on that, it's going to change logic in your actual code. It's going to randomly change greater than into lower or equal, and that kind of change that are actually syntaxically correct, but will change the behavior of your test. And then it runs the test that cover that piece of code. And there can be only 3 solutions. Either way, the code blow up, the test catch the failure, or the test doesn't see anything. And it's actually that part that interests us. If your test did not catch a change of behavior of your code, it probably means that the test is not that good. The problem of that kind of tool is that because the changes are randomly generated over your code, you have to inspect the change that it did because it could have no actual change in behavior. It's just the syntax that changed in PHP, but that's something that you have to go through manually. So it's quite slow, but it's still very useful to determine if your tests are good. As I said, because it's going to try to map your code to the piece of code that is covered by that test, if each of your tests cover hundreds of lines, it's going to take forever to run that kind of tool. And it's going to be even harder to try to interpret the result of that tool. So for instance, on Doctrine, we cannot run it because it would actually take pretty much a month on my machine. So we have a lot of work to improve the test. Now, on the actual structure of the test, the best advice I've got, this comes from Drawer, actually. It's, I don't know, a bit weird that I could never read about that anywhere, but I hope that you're going to find it interesting. You can read about that everywhere. What is AAA? Does anyone know what AAA, AAA is? Sorry? Yeah, that's also batteries. In the field of unit testing, AAA is that idea that you should have three parts in your unit test: the arrange, act, and assert part of your test. It basically means that in the arrange part, you set up something, then you act on it, you call a method on that piece of code, and then you assert a certain result on it. So here we are building just a collection, adding an element to it, and then checking that the element is effectively in the collection object or not. The problem is that there is no way to enforce that kind of stuff. Like, you really have to read your test and see if they're actually following that guidance or not. It's just a guidance, so it might not work everywhere. So far, for me, it has always worked, but maybe someone has an example where it might be not so useful. The arrange part of the test. Here you can see an example where in the arrange part, someone is actually creating two automobiles, then painting one of them and, no, sorry. Yeah. And asserting, wait, what is the test doing? So, someone is creating two cars with two different colors, then painting one with the color of the other and checking that in the end that the color was effectively painted on that second car. Can anyone see any problem that could arise if you write the test like that? Like, it's respecting the arrange, act, assert, but if you have that kind of test, over time, it's probably going to be an issue. Can someone see why? Yeah? Sorry? Yeah. So your object is probably going to evolve, and you might decide at some point that having the color as a string might be not the best idea, and you change your automobile to pass an object that represents the color, for instance, or change anything else in the constructor of the automobile, and you need to change all your tests. You need to adapt that everywhere in all your tests. So to fix that, the advice that you will see everywhere is, oh, but it's easy, just use the setup method. Every unit framework every unit testing framework provide that kind of facilities. One method that will get called every time just before running your test. It works, but it has two issues. First, it means that now all your tests have a dependency on that setup method. And if at some point one of the tests make a change to the object, it might affect the following tests that can run. We have fixed for that now in PHP units, and most of the time it shouldn't be an issue because it's actually PHP unit that's going to make a new instance of the unit testing class and call the setup and call the next test in a completely separate fashion, but still you could end up in a situation, especially when you're trying to mock databases and stuff, where one of the tests do a change that gets persisted, and then the next tests are affected by it. And now you're in a situation where the order in which the tests run is actually important so that they don't fail. And when they fail, you have to start like binary testing all your tests to find which one is causing the issue in your test suite. I've had to do that a few times. It's really painful. So I would advise against using that. The other issue is that although here it might seem like your code is dry because you are only creating the automobile at one place in the setup method, and then it magically gets called everywhere. If you have a few hundred tests and you just read the test, you just see objects that you don't know where they come from, that get called, and then an assertion is made. And it becomes that much more harder to reason about the test. Dry, so dry is for those who don't know, dry is a technique which means don't repeat yourself. It tries to make sure that you refactor your tests in a way that you don't write twice the same piece of code in the same class, for instance, or at least that's the way a lot of people understand it. That can be a whole other discussion, but that's one of the reasons people use the setup method, because then they don't have to write new automobiles everywhere in their test. If you have that test in the middle of a file and you need to scroll at the top to find the setup method, if it's at the top and not at the bottom or somewhere in the middle, it's just a pain to understand how your tests behave. So the next solution that I've also seen, maybe I removed that example. Extracting to a method to the extreme is also hurtful for your comprehension of the test, because we've had clients that ended up in a situation where all their unit tests basically look like that. Initialize, do, and then assert. Again, having that test or not having it is pretty much the same. Now, the solution to that problem that you might maybe know, the builder pattern. Who heard about the builder pattern? Okay. I don't know why. I've never seen anyone use it in unit tests, but it actually makes the unit test that much more readable, and you still get the benefit that if your code changed, you have to change it only in one place. For those who don't know, the builder pattern is just an object that will create your object for you. So here, the automobile builder just has a build method that will return your automobile. On its own, it might not seem very interesting, but if you use that with a fluent interface, so that you have methods everywhere in your builder to change how you can, or change the parameter that you can build your automobile with, then you end up with tests that are much more readable. You actually have an arranged part of your test where you can limit yourself to only specify the stuff that are important for your test. It's not done here, but you could totally imagine that you have a create builder method, but also a create builder with default values that I don't care about. And then on top of that, you just change the part that is important for your current test. The assert part of the test, again, can anyone see a problem in the assert part of that test? Yeah?
If there's an error, the test will run through the whole collection and will stop prematurely.
Exactly. So maybe you might have heard that your test should only have one assertion. It might be not always the case in the sense that there's some good reason to break that rules, but there are no good reason to put an assertion in a for each. If you start putting logic like that in your code, at some point you're just going to need to unit test your unit test to understand, to make sure that they're actually doing what you think they are doing. So as a base rule, it's recommended to only assert one thing. The other reason to only assert one thing is that all the unit testing framework throw exception when the assertion fails, which means that all the following ones won't be run, and you won't get a complete picture of what's wrong in your code. Now, one of the good reasons that I've seen to actually have more than one assertion is, for instance, testing an exception. If you need to test the code of the exception, but also the message, it makes sense to do that in one test. But if you write it like that, again, if it fails at the error code, exception code, you don't know if the message is still the right one or if the message is also in a weird state. It's just an example. There might be better, but it gets the job done. To fix that issue, there is the concept of assert all. It also exists in pretty much any unit testing framework. And it's just that idea that you can write yourself an assertion, that you pass assertion to it, and it's going to run all of them, even if one of them throw an exception, and just rethrow the exception that were thrown in the first place at the end of your list of assertion. Yeah. For some reason, I see also a lot of people that want to religiously stick with one assertion type in all their tests, and they have assert true everywhere. Although that completely works, it makes the default error message completely useless. When you end up in test suite that breaks a few hundred tests, and the only thing that you can find out of those tests is assert true but was false. Yeah, I mean, if the tests weren't there, it was, to me, it's pretty much the same. So picking the right assertion for the thing that you're trying to test means a better error message, and that's what is going to help you fixing the error in the first place. We are only writing tests so that they fail. So when they fail, it would be nice if we could get really fast a good idea of what's the actual problem in the test. And also people get the parameter order often wrong. So supposedly most of the unit testing framework I've seen, the first parameter is what you expect, and then you pass the actual value that you're testing. If you get that in the wrong order, it's also going to make the error message really confusing. Now, another way to have better assertion, it's also something that I've not seen implemented in PHP, but there is no reason why it couldn't be done. And maybe it exists and I've just not find it. It's a library that exists in C# and in Java, and it's called Shugli. And what Shugli allows you, it basically will change your assertion from the one that's on the top, assert same red and then get color, to something like color should be red. When you read the test all the time, that you don't spend doing that whole gymnastic in your head, like, oh, the first parameter is what I should have, and then the second one is what I'm testing. It's a lot of time that you are not wasting by just having it spelled out directly in front of you. It's pretty much English. Yeah, to me it makes the code, the test, much more readable. They also have a very interesting concept of equivalence, where you can say that two objects should be equivalent, but you can exclude some of the property of the object. So here in the example, you, for instance, use a UUID in the constructor of your object. If you try to assert that those objects are the same in your unit test, unless you have a setter to set that ID to null, it's just going to fail all the time on the UUID. In that case, it also makes the test to me super readable. It's very clear that the customer should be equivalent, but the ID. Does anyone has any question? Yeah. So what is your question exactly? How to write code that use dependency injection, or? Yeah. So your question is, what is dependency injection, or? No, I should probably have asked a question, but yeah, who doesn't know what dependency injection is? Okay, maybe people are shy, but no, it's okay. The idea of dependency injection is just that idea that instead of doing stuff like that, where the UUID, for instance, is just created using a static method, which make it impossible for the person that looks at your code to know that it actually has a dependency on a UUID library. Instead of doing that, you make sure that everything that is used in your code is either way passed to the constructor, if it's necessary at construct time, or is passed to the method that uses it. In any case, using dependency injection, in my opinion, is going to make the code more readable, because just by looking at the constructor, you directly know what is necessary for that class to actually do its job. But it's also going to be easier to test, because in your test, you can override all those dependencies easily, whereas it's much harder if it's a static call, or impossible. Any other question? Yeah.
separate that out. So when I see that test fail, I know this is testing the paint method, there's something wrong there. Or this is testing the get method, there's something wrong there.
To be fair, it's just an example. Maybe it's not the best, but to answer part of your question that is about the fact that it's testing at the same time the paint method and the get method, I would not expect the get method to have any logic in it. So it would be weird that it fails. It's totally something that could happen, especially if it's code that you didn't write yourself and code that's existing and that you're trying to unit test. But there, it's just an example. Yeah, that is maybe not the best. Yeah.
You mentioned earlier the verify. I have heard a lot of comments about people saying that when you use verify a lot or you do a lot of partial mocks, you're actually making you have a unit test. So basically, you are really dependent on your implementation. So if the implementation changes a little bit, then all the tests will break, but the unit still works. How do you see that? Do you think it's still valid, or that's already we should try to not do that?
Maybe I did not insist on that part enough, but mock is a fix for a code that is already problematic. If you have to use mocks too much and everywhere, it basically means that your code is structured in a way that everything is dependent on everything, and that makes it super hard to test. And that's exactly what's going to happen. Something is going to change somewhere, and all the tests are going to break. Mock is only there because you have already existing code and you're trying to test a small part of it. It cannot fix all your code at once.
Do you think that verifies falls into that same category problem? Because once you verify that the little method is run inside that unit, it means that always has to be there, even if the unit should work after refactoring.
What do you mean by verify?
So, for example, I have I'm unit testing one particular method, and then I'm verifying that some methods that probably in the unit will run, for example. But then someone comes along the line and refactor that method. So the method will still output what it was doing before, but that method is no longer there. And now you're verifying the fact.
Yeah. Maybe I should use an example where it's actually useful, but in the case that you're showing, it could actually be a problem. I have a hard time finding a good reason to use verify just like on the spot now. But I've seen an example where it was partly justified. I just cannot find a good one just now. We're out of time. Sorry. Thank you very much. Have a good talk.